Any special angles, how do we remember them? Well, this would be a drawing of your left hand. I usually use my right hand though, so let me just, it shouldn't really matter. Let me just draw a right hand. So this is your pinky, and this other one, oh my, this doesn't have this degree. Anyways, and that's your thumb right there. Okay, let's pretend that looks like a hand. This right here, your thumb, the value right here is 0. So let's assume we're using degrees, right? So 0 degrees, then this one would be which one is this? This would be 30. This would be 45. This would be 90. Maybe 90, 60, and then this would be 90. So example, if they ask me to find, if I'm required to find sine of 30 degrees, right? What you're going to do, you see that finger that has 30 degrees on it? Just bend it, like put it down. So, trying to find 30 degrees. This is your right hand, eh? Put it down. Can anybody tell me, if you're checking to the right of that finger, right? So that would be your index finger. If you check into the right of that finger, how many fingers do you have left? How many fingers on this side to the right? 1, right? So what you're gonna do, for all the numbers, you're going to square root the number. So you have 1, right? So you put the square root of 1, and then you always put it over 2. But of course, we know the square root of 1 is 1, and therefore the value of sine 30 is equal to a half. If they ask me to find cos of 30 instead, so let me put cos 30. Instead of looking to the right of that finger, you're going to look to the left of the finger. So you have 1, 2, 3 fingers remaining to the left. So what you're going to do, you always square root that number. So it's the square root of 3, and you always put it over 2. Therefore, cos of 30 degrees is root 3 on 2. So you understand that? Yes? No?
Yes, miss.
Yes, miss.
Okay. Well, let me give you one to try.
Yes,
Oh, shucks. I'm so sorry. They need an undo button. Oh gosh, sorry. I'll wait next time. Say I want to find sine of 60 degrees. So this is the finger I'm looking at. I'm taking this finger off. So you would bend that finger, right? So remember, this is your right hand we're looking at. Bending that finger, which would be your ring finger. Bending it. If I want to find sine of 60, I look to the right. How many fingers do I have to the right of my ring finger? 3. So you always square root that number, so it's square root of 3, and then you always put it over 2. So sine of 60 is going to give me root 3 on 2. If I ask you to find cos of 60, you look to the left. How many fingers do I have? Okay, to the left.
1.
1. Always square root. So this is square root of 1, and then you always put it over 2. But we can simplify this even more because the square root of 1 is 1, and therefore cos of 60 is a half. Let's do another one. Don't worry, I'm not erasing this, just this finger thing right here. If I ask you to find sine of 45 degrees. So remember, these are in degrees, right? That's my middle finger. So you put down your middle finger. I want you to find sine of 45. Can anybody tell me what that value would be? Check how many fingers to the right of this So how many fingers to the right? It's always square root that number and then always put
Square
it
root of 2 over 2.
root 2 and 2. And that's the value of sine 45. So what's the value of cos 45? Anybody? Look into the left. What's the value?
Root 2 and 2.
Root 2 and 2. So that's how you do your special angles. Everybody good with this? Yes? No? Hope that helps. Okay. Yeah, I wasn't into the whole memorizing thing, so I needed to get away for me to remember this is what I did. So now I'm telling you. But this is in radians, right? So what if they ask you about, let me read this now. This is in degrees, but what if they ask you about radians? Well, 0 degrees is 0 radians. 30 degrees, that's pi on 6 radians. 45 is pi on 4 radians. 60, pi on 3 radians. And then 90 is pi on 2 radians. So it's the same method you're using. So if I ask you to find instead of sine of 45, I ask you to find sine of pi on 4, the answer is still going to be root 2 and 2 because you're still using the same method. If I want to find sine of pi on 4, I look to see how many fingers I have remaining to the right of my middle finger. It's 2 in this case, so it's root 2, and you always put the number over 2. So root 2 and 2. Sine of pi on 4 is root 2 and 2. If I ask you to find, let's do another one. So say I ask you to find sine of pi on 2. What would you tell me? What's the answer? Check how many fingers to the right and square root it. Then put it over 2. So what's the answer? Anybody? What's the answer? Just check how many fingers. So, I'm not looking at this middle finger. I'm looking at this pinky right here. And God, root 4 over 2. Right. Why is it root 4 and 2? Well, if I'm looking at my pinky, right? From my pinky, if I put down my pinky, how many fingers do I have to the right? When I'm trying to find sine, we're looking at the fingers to the right. Okay. So how many fingers do I have to the right? I have 1, 2, 3, 4 fingers. You always square root that number, so it's the square root of 4, and then you always put it over 2. But we could simplify this even more because the square root of 4 is 2, and therefore 2 divided by 2 is going to give me 1, and that's why sine of pi on 2, aka sine of 90 degrees, is 1. If I ask you to find cos of pi on 2, which is also cos of 90 degrees, it's how many fingers to the left? How many fingers to the left of my pinky? Anybody? 0. So still doing the same thing, square root of 0 and 2. But like the square root of 0 is 0, right? 0 and 2. So this is going to give me 0. Therefore, cos of pi on 2 or cos of 90 degrees is equal to 0. Everybody good with that? Yes?
Yes, miss.
Nice.
Miss, can you do one more, please?
Okay, which finger didn't I do? I did this. Oh, I didn't do this one. Let me do the 0.
Miss, pi over 2 is the same thing as 90 degrees?
90 degrees. in radians is pi on 2. It decreases. So this is pi on 6. So it's 6, 4, 3, 2. Just to help you remember that. Okay, let me do 0. I can erase this, right? I think I can erase this in sections because since we did that. This. Okay. Are you seeing the screen now? Okay. Well, let me do sine of 0. So sine of 0 degrees, so 0 degrees is the same as saying 0 radians, right? So sine of 0, what do? This is the finger I'm looking at now, my thumb. Remember, this is your right hand we're dealing with, right? Right. So 0, we want to find sine of 0, so I'm looking at my thumb. Put down your thumb. If I want to find sine of 0, I need to look at all the fingers I have to the right of my thumb. How many fingers do I have to the right of my thumb?
0.
0. So whatever that number, we square root the 0, always put it over 2. So the square root of 0 is 0. 0 and 2, which is also going to give me 0. If I ask you to find cos of 0, 0 degrees, or 0 radians. So my thumb is still down, but since I'm looking for cos, I need to look at all the fingers I have to the left of my thumb. How many fingers do I have? How many fingers do I have to the left of my thumb?
4.
4. You always square the number to the square root of 4, and then you always divide it by 2. But we know that the square root of 4 is 2, so that's the same as saying 2 on 2, which is going to give me 1. That's why cos of 0 degrees or cos of 0 radians is 1. You good? You good with that?
Yes, miss.
Okay, and just in case you didn't know how to find tan, and you're interested in finding tan, if you're not like me, well, you are like me, and you don't like this whole memorization thing, and you would want a method to help you remember them, then this is for you. If you understand what to do here, you don't need to memorize anything. Hold on. Today's busy, I believe. Yeah, that's fine. So recall from your trig identities that tan theta is the same as saying sine theta on cos theta. So that's an identity that we did when we were doing trig. So let's say I have, just now we found out that sine of 0 degrees of 0 radians is going to be 0. And then we found out that cos of 0 degrees of radians is 1. So if I want to find tan of 0 degrees of 0 radians, so let me just say if we're doing degrees, it would be sine of 0 degrees on cos of 0 degrees, which is sine of 0 degrees gives me 0, cos of 0 degrees is 1, 0 divided by 1 is going to give me 0. And therefore, tan of 0 degrees or tan of 0 radians is going to be 0. Let's do another one. If I ask you to find I don't know, tan of pi on 4 radians. So remember, pi on 4 is the same as 45 degrees, right? And we found out that sine, let me just put it up here, sine of 45 degrees or pi on 4 radians gave me root 2 on 2. We were doing practicing that just now, right? And then we said cos of pi on 4 also gave me root 2 on 2. Gosh, root 2 on 2. Let me just erase this. It looks kind of jumbled there. So I know that sine of pi on 4 radians is root 2 on 2. Cos of pi on 4 radians is also root 2 on 2. Therefore, if I want to find tan of pi on 4, according to my identity, tan theta is equal to sine theta on cos theta. Tan of pi on 4 is the same as saying sine of pi on 4 divided by cos of pi on 4. Sine of pi on 4 is root 2 on 2. So root 2 on 2 divided by cos of pi on 4 is also root 2 on 2. Okay? So if I simplify this, right? We know whenever you're dividing by a fraction, it's the same as multiplying by the reciprocal. So if I said this, root 2 on 2 divided by root 2 on 2, that's the same as saying root 2 on 2 multiplied by the reciprocal of this, which is 2 on root 2. That's just basic math, right? 2 multiplied by 2 on root 2. You would notice that this would cancel with this would cancel with this, and therefore tan of pi on 4, aka 45 degrees, is 1. Everybody good with that?
Yes, Miss. Miss, don't clear it as it.
Okay, just let me know when you're done. You finished?
Almost, Miss.
Okay. By the way, would you like me to do another one, or you good? Or we could go back to definite integration. Only 40. Anybody else? Anybody else?
Miss, I'm finished now.
Okay, do you want me to do another one, or you good? This is that really your right hand? You said the thumb was on the very left, so yeah, it's your right hand. Your thumb, this here is your thumb. This is your pinky. This is your thumb. Oh my, stop it. Stop. This is my pinky. And this is your pinky right here. Does that make sense? Like, if you lift up your right hand and face your palm towards you, bruh, brain down, relax yourself, okay? Stop. This is my pinky. Jana, does it make sense? If you lift up your right hand and face your palm towards you. Oh, I tell you. Oh, 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 no. I was talking about my palm. Like, Put your palm towards your face. Oh. Okay, so you good now, right? Probably should have made that clear. But anyways, I'm clearing this off now. Okay. This is my PT. I'm not an art student, okay? I did not sign up for that. Let's do, well, you do the second one for me. Let me know when you finish. So remember, all you're doing, follow the rule. A, which is area, integral of f of x, dx, upper limit b, lower limit a. So the upper limit is always the bigger number that they give you. Lower limit is always the smaller number. And just apply your rules, right, of definite integration, and you're good to go. Remember units, unit squared, unless they give you a unit, then do what you know you have to do, you know? All right. So they told you that the equation of the curve in this case is y is equal to, what was it? I have it written down, 2x cubed minus x minus 19. And they want you to find the area of the region bounded by this curve and the lines x is equal to 3 and x is equal to 4. So like I said, this sketch I'm going to draw, this is not what this is. This sketch is not what this would look like. Just to help with your understanding, right? So my Cartesian plane, y-axis, x-axis, we deal with the first quadrant. So let's assume the graph looks like this. It will not look like that. This is a cubic equation, so you wouldn't get a parabolic curve. But anyways, like I said, just for your understanding. We're trying to find the area bounded by these two lines and my curve. The lines are always parallel to the y-axis, so two lines parallel to the y-axis. This value of x right here, so this is my x-axis, right? This value of x right here would be 3, it's the lower number. This one would be 4. Because remember, on the Cartesian plane, you start from the origin, which is, you start from the origin on the x value 0, and then you increase, right? You increase the numbers. So this number might be 1, this might be 2, then you go to 3, and you 4. This scale is kind of off, but you get the idea, right? So this line, I'll say it's x is equal to 3. This one, x is equal to 4. So let's just say that's what we're looking at. And remember your curve, it's this. What we're trying to find, the area bounded by this curve and these two lines. So this green area right here. This is what I'm looking at. That's what I want to find, the area of that region. And how do we do that? Well, whenever you see a question in your exam that requires you to find the area under the curve, you always go back to this formula. F of x with respect to x, to dx. What does that mean for me? For this question, what I'm going to do, A, remember A is the area under the curve, so this green area. The integral of f of x in this case, which it would be my equation of the curve, which is this right here. 2x cubed minus x minus 19. This is with respect to x, so you put your dx. Upper limit b, remember the upper limit is always the bigger number, right? So the upper limit b would be 4, a would be 3. So I put 4, I put 3. And then I just use my knowledge of definite integration to solve this. The first thing you need to do is integrate this expression. When you integrate the expression, you substitute the upper limit, you substitute the lower limit, you subtract the both, you get your value. That's all you're doing, right? So erasing this on top of it. definite integration, what we were practicing before, right? The first thing you do, integrate this expression right here. When I do that, what am I gonna get? This is going to leave me with a half x to the 4 minus a half x squared minus 19x. Remember, when you're dealing with definite integration, you put your bracket there, you put your upper limit, which is 4, your lower limit, which is 3. All you do now, substitute the upper limit, so wherever you see x, you replace it with 4. Let's do that. So my first bracket here, wherever I see x, I'm replacing it with 4. So I see x to the power of 4, that would become 4 to the 4 minus a half x squared would become 4 squared minus 19x would become minus 19 by 4. That's my first bracket. Now I need to substitute my lower limit into this expression. So I just erasing the this little sketching. As we see, wherever I see x, I'm replacing it with my lower limit. So a half x to the 4, this would become 3 to the power of 4 minus a half x squared would become 3 squared, and then minus 19x would become minus 19 by 3. All you need to do now, find this value, subtract them, get your answer. Everybody good with that? Yes?
Yeah, miss.
Okay. You understand how I got this? Everybody? All I did was integrate this expression. But you understand how I got this